Here's our inverse proportionality. That would be y equals k over x. Y is inversely proportional to x. Okay? So I ought to write that to be consistent. Okay? In this case, if you got more x, you're going to get more y, right? X gets bigger, you multiply it by k, the result gets bigger, okay? Here, more x is equivalent to less y, and vice versa. More y is equivalent to less x, okay? Okay, so here. Y equals 10 when x equals 2. What's y when x equals 4? Well,
Five. That's 5.
y equals k over x. So, well, yes, it is, and then we can figure that out because the numbers are simple even without using the process, okay? And if you saw that intuitively, that's really good. But make sure you can use the process as well because the numbers aren't always that obvious, okay? Like in a minute, we'll be able to use proportionality to figure out what somebody weighs if they're on top of Mount Everest versus at the bottom of the Mariana Trench.
Okay, why is...
Not that you'd want to be there.
5?
I'm sorry?
Why is it 5?
Why is it 5?
Because K is equal to
Because Candace said,
Oh, okay, okay.
okay?
Got
And
it.
Candace is
I was
always
thinking,
pretty much,
yes, okay.
most of the time, right. Okay?
Yes.
So Candace might have seen that intuitively. She might have solved the equations. It's on camera. You know, I said something good about you. Don't let it go to your head. I'm going to cut you down in a
We're way
minute.
past that.
Okay, now, okay, so we have 10 equals k over 2, right? So we solve that, so, well, k is clearly 20, right?
Mm-hmm.
So now, our model is y equals 20 over x. So if x equals 4, y equals 20 over 4, which Candace will confirm is 5.
I confirm.
Okay? So this is really easy, right? It's like what we were doing with exponential and quadratic models and everything. But you've only got one data point, essentially, and one constant number, one parameter to evaluate for. Okay? So, very simple. Now, another way of saying this is, of course, if y is inversely proportional to x, then if you double x, you're going to cut y in half. Because y goes down as x goes up, right? If x goes up by a factor 2, y's go down. Y's go down by factor 2. We talk good. Grammar. Okay. Right? So intuitively, there's an intuitive connection. Is that how you figured it out? Or did you do the algebra in your head?
I did the algebra in my head.
That's it. Either way, very good. Okay? Now, and over here, if x gets twice as big, clearly y is going to get twice as big. So you can always ask yourself, well, if this one gets twice as big, what's that going to do to the other one, right? It's a good thing to ask yourself to get a feeling for proportionality. Okay? Which is really a big underrepresented key to understanding I hesitate to say a majority, but I'm going to say it anyhow, a majority of mathematical relationships that are going to be important to you, or that might be important to you. So if you're good at this, it opens doors that otherwise would confuse you, cause you ulcers, and all kinds of terrible things. Okay?